Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rules in computing the derivative of this given function. Our function is a rational function which has -2 cosecant x on the numerator all over 1 minus cosine x on our denominator. And since this is a rational function, or also known as a quotient of two functions, we are going to use here the rule in differentiating rational or quotient of functions. It's actually structured in this manner. Okay, if we have k of x over m of x, where m of x is not equal to 0, the rule for that follows this idea: the denominator rather, times the first derivative of the numerator minus the numerator times the derivative of your denominator all over the square of whatever would be in our denominator. So it's very important to be really guided with this, because you cannot interchange the terms in your numerator because it's under subtraction. So looking into this, before we can get its first derivative, let's structure here k of x, our numerator. That's -2 cosecant x. So this is a constant multiples. We're also going to use some of those important rules. So the first derivative will take out -2, and then the derivative of cosecant x is negative cosecant x cotangent x. So simplifying that, negative times negative, we have 2 cosecant x cotangent x. Okay, that's for the derivative of our numerator alone. For our denominator, m of x, it's identified as this: 1 minus cosine x. So this is this will use the derivative of a sum or difference. So its first derivative for the constant at 0. If you're minus, the derivative of cosine x is negative sine x. So simplifying that, it's just actually positive sine x. Okay, so with all of this already given, let's use this rule in providing the derivative of our given function. Let me cover here so we can see the final form. So the denominator, m of x, is 1 minus cosine x. I think the space is not enough, so let me extend it further until here. Hopefully you can still follow the rule. So we have here our denominator, which is this: 1 minus cosine x times the derivative of our numerator, which is this: 2 cosecant x cotangent x, minus our numerator, which is -2 cosecant x times the derivative of our denominator, which is sine x. And these are all over 1 minus cosine, or the square of 1 minus cosine x. Take note, you cannot just distribute that because it's a binomial expression. Take note, our numerator here, or I mean this first term, is a binomial expression, so you have to distribute that in two terms. So you have here 2 cosecant x cotangent x, then minus 2 cosine x cosecant x cotangent x. This becomes plus 2 cosecant x and then sine x all over the square of 1 minus cosine x. Okay, so after then, look into this relationship in this, because this can be still simplified. This is okay because you can no longer simplify cosecant and cotangent if you would like to just simply look into the appropriate forms. So what we can do here is this: 2 cosecant x cotangent x. You have here minus 2 cosine x. Cosecant is 1 minus sine x. Cotangent is cosine x over sine x, plus 2. Again, cosecant is 1 over sine x. And we have here sine x all over 1 minus cosine x, the square of that. I'm talking about this because you can cancel this. You have here sine and 1 over sine x or cosecant x, so you can simply multiply it to 1. Here as well, as you multiply this, you will have cosine x over sine x, and there are 2 of them. So as you multiply that, you will have cosine squared over sine squared x. That would mean it's cotangent squared x. So you will have here 2 cosecant x, cotangent x minus 2, the square of cotangent x, and just simply just plus 2 here all over the square, 1 minus cosine x, the square of that. Now, since you can no longer, what you can do in numerator is simply factor 2 and leaving all the terms. And again, you cannot simplify this anymore. So this is one of the versions of the answer. Again, you can simplify this. That's already the final answer for this given item here. Take note, we have used here appropriate rules on trigonometric identities together with their differentiation rules, the quotient rule, and the what do you call this one? These rules for the constant multiple and for sum and difference. Thank you very much for watching. So what are you waiting for? Subscribe now.